Hi everyone, just want to say welcome to video number 16, I believe. And anyway, that's a good place to be. We're going to talk in section 11.7 about and probabilities and a few other topics. This will be a longer video than the last few, and there's a quote up above just to get you started for the day. You can let me know what you think about it when I get back on Wednesday. So our first big concept for this section in chapter 11 is the concept of independent events. So when are two events independent? They are independent if the occurrence of either event has no effect on the probability of the other event occurring. So for instance, if I toss two coins at the same time, a quarter and let's say a dime, is the fact that the quarter lands on a heads, is that going to affect the probability of the dime landing on a heads or a tail? And the answer is no. So those would actually be independent events in some sense. Now, when things are independent, that leads us to another kind of problem and a formula. So I want to toss some coins for you so you can see how that works. So I have two coins. I got a dime and a quarter, and I'm going to toss both of those coins at the same time. And what I want to do when I toss them is I want to record the sample space, and so when I toss them, then this is what I get for the sample space. I could get either a head and a head on the two coins, or a head and a tail, or a tail and a head, or two tails with both of the coins. So there are four total outcomes in this sample space. So, but the real question I want to answer is, what would be the probability of getting a tail and then a tail, let's say, of getting two tails on those coins? Well, from the fundamental counting principle and its application to probability, what I'm trying to get is the probability of a tail and a tail, like that. And to do that, I know that the probability of getting one tail is 1 out of 2 on, say, the dime, and the probability of getting the other tail is 1 out of 2. And I'm always curious as to whether I add or multiply with probabilities. And in this case, you can see that there are 4 total elements in the sample space. So I know I need to multiply that 2 and the 2 to get 4. So that tells me a little bit that I have to multiply those. And so the product of getting a tail and a tail is equal to 1/2 times 1/2, which is 1/4. And that's exactly what we see in this sample space. So there are a couple of things going on here I want to point out. First one is, somebody's going to describe some type of experiment, tossing 2 coins, tossing 3 coins, etc. It is very important that you have a method that helps you understand what is in the sample space. In this case, I listed the letters a head for the first coin and a head for the second coin. And once you do that, when you start to ask what's the probability of getting 2 tails, you're really saying getting a tail on the first coin and a tail on the second coin. Or getting a head and a tail, that's the probability of getting a head on the first coin and a tail on the second coin. So remember that these kinds of problems are always and problems. Okay, next slide. So we can see here that if two events are independent, sorry, that's a big word and couldn't fit it, if two events are independent, then the probability of A and B, event 1 and event 2, is equal to the probability of event 1 multiplied by the probability of event 2. Now, the one issue you have to keep track of, always look for the words or and. If the word is or, then you need to look for mutual exclusive to decide what formula to use. But if the word is and, then you need to decide whether the events are independent. So make sure you keep that straight so that you'll be able to deal with those issues as you start to do problems. So here are a couple of problems you can try. What I want you to do is roll a single die 2 times. So you're taking one die, you roll it, record the number, take that same die and roll it again. What I want you to do is find the probability of getting a 2 the first time and then a 5 the second time. And then the next problem is same die, roll it twice. What's the probability of getting a prime number the first time and a number less than 2 the second time? So try both of those, pause this, and then come back and check and see if you got the answers right. So the solutions are listed here. The first thing I need to check for is the idea of independence. And if I'm rolling a single die, does the probability of any number on the first die affect any number on the second die? And the answer is no. Therefore, these are both and probabilities, and they're both independent, so I can multiply to find the solution. Probability of a 2 and the probability of a 5 are both 1/6. Therefore, the solution is 1/36. Probability of a prime is 3/6. Probability of a number less than 2, that's just 1. So that is only 1 out of 6. And therefore, when you multiply, you get 3 out of 36, or 1/12. And so finally, here's another problem. It says, the probability that Nathan Kane will have a moment of talking in class is 2 out of 3. What is the probability Nathan talks 2 days in a row? And so the question is, are these independent? Well, sure, if Nathan talks on one day, that doesn't really affect whether he talks or not on the next day. So you can assume independence here. So how would you write a solution to the problem? And so, hopefully you've had enough time to pause, but so what's the probability of Nathan talking 2 days in a row? Well, it's the probability of talk day 1 and talk day 2, and essentially that's equal to the probability of talk times the probability of talk, since they're independent. So it's 2/3 times 2/3, or 4/9. So the reality is there's less than a 50% chance that Nathan will talk 2 days in a row. I must have that probability wrong. Just kidding, Nathan. So for our last problem, we're going to talk about another strategy you can use when things are dependent, not necessarily independent. And what usually happens in dependent is that, suppose I have this chocolates in a box. 8 of them are Nutty Chews, 5 are caramels, and 10 are those cherry nasty things, so the cherry nasties, all right, which I don't like. And so this is my box of chocolates, and so I can't see inside the box, so I just reach in and pull a chocolate out. And what I'd like to do is find the probability of pulling 2 Nutty Chews out, since those are my favorite. And how could I find that out? So one strategy is to use what's called a tree diagram to kind of outline the probabilities as you work through it. And so it's a great way to do it. And so I want to show you how that works over here on the right side. So what I'm going to do is I want to pull 2 Nutty Chews out. So my first step is, what are my choices? Well, what I notice is I have 8 Nutty Chews. So these are the nutties. And then we'll call this everything else, or the non-nutties. All right, let's erase that and call it the non-nutties. I like that so much better. The non-Nutty Chews. All right. And there are 15 of those. So if I was counting, that's what I would do. But I'm not counting, I'm doing a probability. And so this would be 8 out of a total of 23, and this would be 15 out of a total of 23. Now, once I have those, then I'm going to draw again. So because I want to take 2 chocolates out. And so if I draw a Nutty Chew first, then when I draw again, I could either get a Nutty Chew or I could get a non-Nutty Chew. So a Nutty Chew. Now I've already drawn one out, so there are going to be 7 of those, and there are only 22 left. In this scenario, there will be 15 of the non-Nutty Chews, but 22 left because I took out one before. In the same way over here on this next branch, this will be 8 out of 22. Can you think why? And this last one will be 14 out of 22. Make sure you can explain to yourself why that's true. And so what I want to do is find the probability of getting a Nutty Chew and then another Nutty Chew. So this is an AND problem as well, but it uses what we call our dependent events. Now, why are these events dependent? And the reason is because they are dependent because the probability changes. It doesn't stay 8 out of 23 because I already took one of those Nutty Chews out and ate it. Well, if that's the case, then the probability of dependent events is really equal to the product of these branches. So it's still equal to the probability that I got a Nutty Chew on the first time times the probability that I got a Nutty Chew on the second one, given that I got a Nutty Chew on the first one. And that's why I'm going down this branch. It's those two things. Another way to say this is, what's the probability of getting 2 Nutty Chews? Okay, and in that case, that would be 8/23 times 7/23, which is 56 over 529. Alrighty, that's all for the video now. Good luck on your homework.